Good afternoon, dear students. Today's session we will discuss about heavy water and hydrogen peroxide. In the previous class we already discussed hardness of water, temporary temporary hardness of water and permanent hardness of water. Today's class will start from heavy water. So what is the formula of heavy water? D2O. D2O is the formula of heavy water because why we call this one as heavy water? D means deuterium is the isotope, one of the isotope of hydrogen. So the general name you can say this is oxide of heavy hydrogen or oxide of deuterium, you can say this. Okay, another name of heavy water, oxide of hydrogen or oxide of deuterium or oxide of heavy hydrogen. So deuterium is a heavy hydrogen, it's a heavy isotope, so you can call this is heavy hydrogen. It's not a naturally occur element abundantly, but you can synthesize this heavy water from the normal water. How to synthesize the heavy water from the normal water? By the process of electrolysis of water. So if the electric current or the electricity is passing through the water, passing through some amount of water, it will liberate the hydrogen which is present in the normal water. Then after liberating all the hydrogen from the water, the remaining solution contain this deuterium contained water. That means heavy water in that solution in the electrolysis process. So it is not an easy process, but we can we are synthesis this heavy water from the electrolysis of water. So one part of heavy water is present in 5000 parts of normal water H2O. So less percentage of heavy water is present in the normal water. 5000 part of normal water contain only one part of heavy water. So the physical properties of this heavy water, D2O's physical property, it is a colorless one and it is odorless one and it is tasteless liquid. So colorless, odorless and tasteless liquid. And we have some chemical properties for this heavy water. Chemical properties. When compounds containing hydrogen were treated with the heavy water, this deuterium is exchanged with the hydrogen. So the compound contains hydrogen, that compound is treated with this heavy water, then what will happen? This heavy water contains deuterium, this deuterium is exchanged with the hydrogen. For example, take sodium hydroxide, treating this sodium hydroxide with the heavy water D2O. Now what will happen? This hydrogen is replaced or it is exchanged with the deuterium is present in this heavy water. So now this hydrogen is replaced by this deuterium. One hydrogen is replaced by one deuterium. So what will be the result? NaOD plus this hydrogen is removed by 1D. So 1D is placed in the place of hydrogen and this hydrogen 1O and 1D is remaining. So HOD. Okay, this is the byproduct. Next example, to see this exchange of deuterium with a hydrogen containing compound, hydrochloric acid is combined with deuterium or heavy water. Now this hydrogen is replaced by deuterium. It will become DCl. Hydrogen exchange with the deuterium. So in the place of D, hydrogen is substituting here HOD. Next example, NH4Cl 4D2O. This 4 hydrogen is replaced with the deuterium. Okay, now ND4 already you have 4 into 2 8 deuterium. Okay, so 4 deuterium is exchanged with the hydrogen ND4Cl plus 4. This 4 hydrogen is combined with the another remaining 4 deuterium and 1 oxygen. So it will become 4HOD. Okay, this is the last example for exchanging deuterium with the hydrogen. This exchange reaction is very useful for determining the number of ionic hydrogen is present in the compound. This is one of the use of this chemical property or from the heavy water. When hypophosphoric acid treated with deuterium, it replaced only one hydrogen from the hypophosphoric acid. For this reaction, hypophosphoric acid H3PO2 treated with deuterium D2O. Now, from this hypophosphoric acid, only one hydrogen is removed by D. That means deuterium. So, it will become H2 because one hydrogen is exchanged with the deuterium. So, now H2D, one hydrogen is replaced by or it is exchanged by D, then PO2. And one hydrogen is combined with one deuterium and one oxygen because one deuterium is replaced with one hydrogen. So one deuterium go along with the hypophosphoric acid and the resultant for this compound is HOD. You can see this, we have two deuterium but only remove one hydrogen. This is denoting that only one hydrogen atom is exchanged with the deuterium, is denoting it is a monobasic acid. Hypophosphoric acid is a monobasic acid. And deuterium or the heavy water is useful for the formation of some deuterium combined compound. For example, Al4C3 combined with 12D2O 4Al OD thrice. So, deuterium compound. Then its result CT4. The next example, CaC2 treated with the two molecules of heavy water D2O, it gives CaOD twice plus C2D2. So they form the deuterium present compound to exchange with the other compound. Okay. Heavy water is a useful one in our daily life. So what are the uses of heavy water? I am going to discuss in this. Heavy water is using as a moderator in nuclear reactors. It is used to reduce the energy of fast moving neutrons as a moderator in the nuclear reactor. And the second one, It is used as a tracer in the study of organic reaction mechanism, and it is explaining the metabolic reaction of mechanism. Third use, it is also using as a coolant in nuclear reactors. So coolant means what? It is absorb the heat which is produced in the nuclear reactors. Next important compound of this hydrogen compound is hydrogen peroxide. This is one of the most important peroxide. Formula of this hydrogen peroxide is H2O2 is the formula of hydrogen peroxide. Now, the preparation of this hydrogen peroxide, we used here some metal peroxides with the dilute acids for preparing or the synthesis of hydrogen peroxide. Treating this barium peroxide with dilute acids. Dilute acid, we took here dilute acid is sulfuric acid, H2SO4. Now this metal is combined with the sulfate, and now it's become BaSO4, and the remaining part H2O2 both are combined, and now they become H2O2. So hydrogen peroxide, the preparation of hydrogen peroxide. Not only from the barium peroxide, it's also we treated here sodium peroxide with dilute acid like sulfuric acid H2SO4. Now this will, the same process is going on, that means H2O2 are combined together and Na2SO4 is combined together. So now the result of this process is Na2SO4 plus H2O2. In the laboratory, we use this method to synthesize hydrogen peroxide. But in the industry method or for the commercial preparation for this hydrogen peroxide, we use the another method to prepare this hydrogen peroxide. The synthesis of hydrogen peroxide in another method, it's known as auto-oxidation of two alkyl anthraquinol. So auto-oxidation of 2-alkyl anthraquinol. For this process, we took here the reactant as 2-ethyl anthraquinone reacting 2-ethyl anthraquinone. Adding hydrogen or reducing this 2-ethyl anthraquinone with the hydrogen. So addition of hydrogens, 2-ethyl anthraquinone. This compound is known as 2-ethyl anthraquinone. It is undergo the reduction with the adding hydrogen in this with the help of catalyst. 2-ethyl anthraquinone is undergo the reduction with the adding the hydrogen in the presence of catalyst. It's produced here addition of hydrogen in this 2-ethyl anthraquinone. Now this hydrogen is added with oxygen. So one hydrogen here, hydrogen will be like this, bond between that two hydrogen. The bond is broken here, and now this hydrogen is combined with this oxygen, and another hydrogen is combined with the next oxygen. So they become OH. Here also it's become OH. Now the same one with this auto-oxidation of alkyl anthraquinone. This is anthraquinone. In the 2-ethyl anthraquinone is undergo the oxidation with the addition of oxygen molecule in this compound. Again it will become addition of oxygen compound. Okay, so now it will become, this hydrogen is removed from this 2-ethyl anthraquinone. Now this 2 hydrogen is combined with the oxygen. So the result of this reaction is C2H5 Now this bond is broken here. They will form the bond between these two carbon, and this electron is combined with the oxygen. Here also it is combined with the oxygen. So it is become double bond. It become double bond. Now this is remaining the same. So removal of hydrogen from this 2-ethyl anthraquinone with the addition of oxidation, or with the addition of oxygen. That means auto-oxidation of 2-ethyl anthraquinone. Alkyl compound is a ethyl compound. Okay, so 2-ethyl anthraquinone. So what you got in this resultant, 2 hydrogen is combined with the 2 molecules of 2 oxygen. So it will become H2O2, O2 and H2. And the major product it's produced in this reaction is 2-ethyl anthraquinone. What we treated in the beginning of this reaction is 2-ethyl anthraquinone is undergo the reduction in the presence of catalyst, and it will become 2-ethyl anthraquinol. Then again 2-ethyl anthraquinol is get oxidation in auto-oxidation reaction. It will become 2-ethyl anthraquinone, and it's produce H2O2. That means hydrogen peroxide. So from this resultant solution, only 40% of hydrogen peroxide is prepared in this reaction, and the remaining 60% is 2-ethyl anthraquinol. So in this you have 2 layers, organic layer and aqueous layer or water layer. So water layer means it contains H2O2 or hydrogen peroxide only 40%. Organic layer means 2-ethyl anthraquinol, it is 60%. This is the industrial synthesis of hydrogen peroxide. Hydrogen peroxide has some physical properties. If it is a pure hydrogen peroxide, it is almost a colorless liquid. Almost it is a colorless liquid, but with the shade of pale blue. It is a less volatile compound. And more viscous than water. It is more viscous than water. Then 30% of solution hydrogen peroxide is commercially, we know that 30% solution of hydrogen peroxide is 100 volume of hydrogen peroxide. We said that 30% of solution of hydrogen peroxide is 100 volume of hydrogen peroxide. If liberated, this 100 volume of from the 100 volume of hydrogen peroxide, only 1 milliliter, okay, from that 30% solution, only 30% solution of hydrogen peroxide, usually know that 100 volume of hydrogen peroxide. Now treat this 1 milliliter from that 30% solution of hydrogen peroxide is heating or liberating. It will liberate 100 milliliter of oxygen. Okay, so 1 milliliter of 30% solution of hydrogen peroxide, okay, from that solution we took only 1 milliliter. Now heat this until the liberation of the gas from this solution. Then you will get the liberation 100 milliliter of oxygen from that 1 milliliter of 30% solution of hydrogen peroxide under the standard temperature pressure condition. These are the physical properties of this hydrogen peroxide. Next one is chemical properties of hydrogen peroxide. Hydrogen peroxide is a highly unflammable and stable compound. And the aqueous solution is spontaneously disproportionate to give oxygen and water. So the aqueous solution means aqueous solution is spontaneously disproportionating this hydrogen peroxide to produce water and oxygen. So when hydrogen peroxide in the solution of water, that will automatically it is disproportionating this hydrogen peroxide into water and oxygen. Okay, so this is disproportionation reaction. The spontaneous disproportionation reaction is undergo in the presence of aqueous solution hydrogen peroxide. Anyhow, this is a slow process, but it is an explosive one to disproportionation of hydrogen peroxide is a slow and explosive reaction. Next chemical property, we can't store this hydrogen peroxide in glass bottle or glass vessels. Why? Because glass bottle or glass vessels contain some alkali metals. This hydrogen peroxide have the capacity to dissolve this alkali metals from that glass bottles. Okay, from that glass it can easily dissolve this alkali metals which is present in that glass. That means disproportionation reaction. So because of this dissolving the alkali metals in the glass, we can't store this hydrogen peroxide in glass bottle or any glass vessels, but we can store this in a plastic bottles or wax coated bottles. Wax coated bottles. The next most important chemical property of this hydrogen peroxide, it can act as reducing agent, also oxidizing agent. This is one of the unique property of this hydrogen peroxide. It can oxidize or reducing the compound. We can oxidize or reducing the compound with the help of this hydrogen peroxide. The oxidation reaction is usually performing in the acidic medium. So the reduction reaction will happen or it is performed in the basic medium. Oxidation reaction in acidic medium. Reduction in basic medium. For this acidic reaction and the basic reaction, H2O2 added with H+, 2H+ ion with the addition of 2 electrons, it will result to H2O. So the energy, the enthalpy of this reaction is plus 1.77 volt. So the overall reaction is present or it is happen in the acidic medium. For example, FeSO4 2 molecules, 2 moles, H2SO4 with the addition of H2O2. So it may form Fe2SO4 thrice plus 2H2O. So it is present it is going on in the acidic medium oxidation reaction. So it is undergo the acidic medium. The hydrogen peroxide is reacting here in the acidic medium oxidation reaction. Next for basic medium. HO2 minus plus OH minus, it produce O2 H2O and 2 electrons. So releasing 2 electrons. So the total enthalpy of this reaction is plus 0.08 volts. So the overall reaction for this basic medium, for example reaction is in aqueous medium, 2 moles of potassium permanganate in the aqueous medium treating with 3 molecules of hydrogen peroxide. It is also in aqueous medium. It produces here 2 molecules MnO2 plus 2 moles of KOH plus 2 moles of H2O and 3 moles of O2 is produced here. Okay, O2 is produced here. Now you can see the result. O2 and H2 is producing when releasing 2 electrons. Okay. So today's session over. Thank you, students.